Hi class. So this is the second part of the 1.3 lesson. So we're doing 1.3 part 2, which is page 6. If you were able to print out the notes that I gave you, that's page 6. So we're going to continue with those notes here, and we're going to look at 3 laws that are really important for algebra. So they're also called properties of algebra. One of them is called the commutative property. And the properties some of them are really straightforward and obvious, but we kind of need to say them and talk about them and have a little understanding, even though they're obvious, because they're critical. Without them, algebra doesn't work. Here's the first property. If you add a number, a plus b, to another number, add a to b, it turns out you get the same outcome if you take the second number and add it to a. So it doesn't matter what order we add these numbers in. So the commutative property is about order, the order of our numbers. So that's the key thought here. Order doesn't matter. Okay, now the second law, it has 3 things in it. A plus B plus C. Now the associative property is not about order, and it's not about 3 terms that we're adding, or 4 or 5 or 6 or 7 terms. It's not about how many terms they are in. Associative property is about groups. You know, like, who do you associate with? You have friends. You have a friend group. So the associative law or associative property says if I group A and B, that means A and B are added first. But the associative law says now notice the order is the same. It's A, B, and C, A, B, and C. I haven't changed the order. The associative law is not about order. The associative law is about groups. And it says that if you add A and B first, you get the same answer if you group B and C. That means we add B plus C first and then add A. So the associative law is about groups. So in both of these laws, what it says is you can change things. Sometimes we need to do that to make it simpler. You can change the order of your math because of the commutative law. You can change the groups that you make because of the associative property. And then thirdly, the additive property, that's probably the most intuitive one. The identity for adding is 0. A plus 0. If you add 0 to anything, you get identically what you started with. Now that one is super obvious. It has a formal name, a fancy name, even though it's so obvious, but we need it. That's an important principle. Without that working, algebra does not work. So, some examples of the commutative law. I'm just going to use our commutative property. I'll just abbreviate here. So, if we go 7 plus 11, we know that's 21. What if we change the order and do 11 plus 7? It's the same. 11 plus 7 is still 21. We get the same answer either way. Now, just a little side note here.
7
minus 11. If we do 7 minus 11, and maybe we change that to adding 7 plus negative 11, and we're going to get negative 4. What if we change the order? 11 minus 7. 11 minus 7 is positive 4. These are not equal. So what that tells us is subtraction does not follow the commutative property. The commutative property is only true for adding and multiplying. Turns out you can do this with adding or multiplying. So if we did, let's say we did 7 times 11, we can change the order. 11 times 7, and we still get 77 either way. But for subtraction and division, they are not commutative. If you change the order of subtraction, you're going to get a different answer. If you change the order of division, you get a different answer. So they're not equal when you change order. Excuse me. Okay, the associative law. Now, remember the focus of the associative property, or the associative law. It's about groups. It's not about order. So, if I do 7 plus 11 plus 4, and I group 11 and 4, well, what is that? What's the same answer as this? Well, it would say, hey, we grouped 11 and 4. If we change the group, 7 plus 11, so now notice I changed the group to be the first two instead of the last two. And I add them this way. So this would add 11 and 4 first, which is 15. 15 and 7 is, what is that? 15 and 7 is 22. 21, 2, 3, 25. My math brain isn't working right now. But that's 22. So, we get 22 if we add these with 11 and 4 first. But what if we add 7 and 11 first? Well, we get 18 plus 4. That's also 22. It works. And what changed? We changed the groups. So don't focus on the fact that there's parentheses are there. Because notice these two have parentheses. It's not about the parentheses. It's about what numbers are grouped. This works with multiplying. If we do 2 times 5 times, oops, I don't want that yet. 6. Let's say we group these two. 2 times 5 is 10, times 6 is 60. But what if we change the group? What if we group those two first? 5 times 6 is 30, times 2 is 60. It's the same answer. They're equal to each other. So if I change the group in multiplying, it's the same answer. So these are following the associative property. I'm not going to write down the additive identity. Hopefully that one is so straightforward. 5 plus 0 is 5. X plus 0 is x. But let's do a couple more. Here's a tricky one. 7. I keep using 7. Plus 8 plus 2. Now I'm going to do, and I'm going to group 8 plus 2. Okay, this one's tricky, and I want you to think about which law did I use. Am I using the commutative law that says I changed the order? Or am I using the associative law, which means I changed groups? Now, if we were in class, we'd have a discussion about this, but we're not here. So what changed? It has parentheses, right? If it has parentheses, it's the associative law? No. The associative law is not about parentheses. It's about changing groups. 8 plus 2 is a group. Did I change the group? Nope, it's still 8 plus 2. The group did not change. It's not the associative law. What changed? 7 was in the front. Now 7 is in the back. This is a change in order. So this one is about the commutative law. All right. So let's say we do x plus y plus z. I'd like you to use the associative law and rewrite that one. So pause the video and write down what is x plus y in a group plus z equal to if we're using the associative law. Okay, hopefully you did that. And so associative law is about changing the groups. So if I took x plus y plus z and I made a group around yz, that would be the associative law. Now, it wouldn't necessarily be the only answer. As long as you're changing the groups, x plus y, you could do, this is trickier, but you could do x plus z plus y. Now, that's a trickier answer. It's true, because x plus y was the group, and now it's x plus z. But it's not only the associative law. This is doing lots of changes. I changed the group from x and y to x and z, but I also changed the order of y and z. Y and z got moved into different order. So this one is the associative and the commutative. So we're doing a couple of different changes here. Okay. So these are important laws. We'll see some more of these as we add on in the next lesson. But one more thing. I want to give you some important vocabulary. A big part of algebra is going to be working with formulas. And there are some formulas that are just formulas that we use in science all the time. Science or math. And here's one of them. Distance equals rate times time. And there's a little formula for it. D equals R times T. D equals distance. R is the rate. And rate just means the same thing as speed. And T means the time. Now, let's assume we're driving our car and we're going 60 miles per hour. So we can take the R out and put in the 60 miles per hour. And now the formula is just D equals 60 times T. That's when we're driving our car 60 miles per hour. So what I'd like you to be able to find is the distance we've gone if we've been traveling for 3 hours. Well, we can use the formula. D equals 60 times T. And since they told us T equals 3 hours, we're going to take the 3, our time number, and plug it into the time spot. So we'll have D equals 60. We're going to take the T number out and replace it with 3 hours. And 60 times 3 equals a distance of 100 180 miles. Okay, hopefully that makes sense. That wasn't too hard, but we're just plugging numbers into their position in the formulas. Here's a 5 hours. So we're going to do it again. We're going to take the time variable out and replace it with 5 hours. So we're just plugging in 5 hours. We're going to do the math. 60 times 5 equals 300 miles. Okay, so this idea of plugging into a formula, we're going to do that a lot. It's good to kind of get comfortable with that. Now, here's an important word that we need to understand for making mathematics powerful. Mathematics becomes powerful if we can use it to interpret the real world. And one important thing in the real world is the idea of change. That's important. You know, how much does your bank account change? How much, how much does the distance change? Or how much does the house change? All kinds of things change over time. With work, there's lots of change in work. So change is a really important time. Change is the difference between two quantities. Now, difference is just a fancy word for subtraction. So if you need to find change, which we will need to find change for lots of different things, it means subtracting. So find the change in distance between our times of 3 hours of driving and 5 hours of driving. How much distance did we change there? So we usually do change by subtracting. Change is going to be subtracting the end minus the start. So in our case, we want the distance at 5 hours. I'm using that little subscript 5 to tell me my distance at 5 hours. That's my end, minus the distance at 3 hours. Okay. So right here, this is like the distance at 5 hours. That's 300 miles. And this is the distance at 3 hours. It's 180. So if I want to find the change, I would be subtracting 300 minus 180. I get 120 miles is the change between 3 and 5 hours. Okay, so remember this about change. It's a difference of two quantities, and often it's subtraction of the end minus the start. Hey, hopefully that helps. Use that to get you going. There'll be another video on fractions. We ran into this in class, these harder fractions. How do you find the common denominator? I'll give you another video on that. Probably won't be my video, but I'll make sure you have that. Hey, study hard. I'll see you guys on Monday. Bye-bye.